In this video, we'll show automated integration testing for M-plane supported radio unit with OAI-GNB. We start by reading parameters from a user-provided JSON file. The JSON file includes GNB configuration such as bandwidth, SSB frequency, MIMO mode, and more. It also contains the SSH login information for each component. Next, the DU parameters are adjusted in the OAI-GNB configuration file. Then, the RU parameters is adjusted using the configuration service via the Open FrontUL M-plane. After that, we verify that the DU and RU are synchronized using PTP. Then, bring up B5G core network and OAI-GNB. Once started, we check that the NG setup is successful. Next, we verify that all packets received by the RU are on time. Finally, the UI's airplane mode is turned off to allow it to attach to the RAN. Now, let's take a look at the demo video. First, we set the JSON file to run with MIMO 2x2 and a bandwidth of 100 MHz. Second, the OAI-GNB configuration is updated based on the parameters in the JSON file. After the DU configuration is successfully updated, the configuration service displays the DU status as up in Grafana. Next, the RU configuration is matched based on the same JSON file, and the configuration service sets the parameter values accordingly. It then monitors the RU configuration status until it becomes active, indicating that the configuration is complete. Once the RU configuration is successfully updated, the configuration service will also show the RU status as up in Grafana. Next, we verify that PTP synchronization between the DU and RU is successful. We can see that the RU sync status that get from configuration service is also matching RU log. Then, we start the B5G core network and the OAI-GNB. Now we can see the OAI-GNB logs starting to print. At this stage, the system checks that the NG setup has completed successfully. After the GNB starts running, the RU begins receiving packets from the DU. We then need to check whether the RU is receiving the packets on time. We can see that it has detected downlink U-plane late packet. In the RU log, it also shows that the downlink U-plane late packet is increasing. So now, we need to adjust the DU's timing window to ensure that downlink U-plane packets are not late. After adjusting, the OAI-GNB needs to be restarted. We then check the RU's packet receiving status again. This process is repeated until the RU receives all packets on time. So now, the RU is receiving all packets on time. The RU log also shows that the number of late packets is not increasing. Next, we can use the UE to attach to the GNB. We let the UE lock onto the frequency of the SSB to ensure it receives the signal from our GNB. Then, we turn off airplane mode. We can see that the UI's airplane mode is off and has successfully connected to the 5G network. To simulate a configuration change, we let the end-to-end system run for a while. Then, we set the UE to airplane mode. Next, we load a new JSON file configured with MIMO 4x4 and 40 MHz bandwidth. We then repeat the same process to bring up the entire end-to-end system using this new configuration. Next, we go back to check the signal messages received by the UE in the first test. We can see that the SSB frequency ARFCN is 649920 and the bandwidth is 273 RBs, which corresponds to 100 MHz. We can also see that the OAI-GNB is using 2x2 MIMO by checking the number of active ports. Now, the RU is being reconfigured because we changed the bandwidth. The RUM plane service log will print out the configuration status also. Because we already finished adjusting the timing window in the previous test, RU will not receive any late or early packets this time. RU log shows all packet is on time. After all components are successfully brought up, Grafana will show the status as up. We can see that the SSB ARFCN has changed to 641280. And the bandwidth is 106 RBs, which corresponds to 40 MHz bandwidth. And OAI-GNB is running using 4x4 MIMO. We have measured the power consumption under different MIMO configurations. When switching from MIMO 2x2 to 4x4, the RU power consumption increases. This is the end of demo video. Thank you.